It's Jan Beta, and today I'm going to take a look at this 1764 REU RAM expansion unit for the Commodore 64. In fact, this thing also works with the Commodore 128, but it is said to have some timing issues on that machine, so it is mainly aimed at the Commodore 64, which it also says. As you probably know, and the Commodore 64's name suggests, the Commodore 64 came with 64 kilobytes of RAM. So it wasn't a lot in the later years of its existence. So in 1985, when Commodore released the 128 and other machines actually, they decided to offer RAM expansions. There's a couple of these with different memory configurations. These are relatively rare as far as I know. They didn't produce many of these. There are only a very few use cases, at least there were back in the day. You could use them as a RAM disk in GEOS, for example. There is a couple of programs that can use the extra RAM. These also came with a disk with some programming examples and things like that. And you could use them for your personal programming enjoyment. Unfortunately, they didn't manage to make the RAM available directly in BASIC, so you couldn't really use it to fit larger BASIC programs in, which would be a nice touch. But this has to be specially addressed to make use of the RAM. Yeah, let's just have a look at this. This is a cartridge port connector that fits in the Commodore 64's cartridge port. And yeah, it's made in Hong Kong, as it says on the back sticker here. This particular unit came from the flooded basement I already restored some machines from. So this is a bit corroded and we have to clean it thoroughly before I even try to use this. So the first step is to clean this up and see if it's working. And after that, I am going to try to expand this. Actually, the 256K expansion that this is can easily be expanded to be a full 1750 RAM expansion, which has 512K, by just putting some extra RAM ICs on there, because it is basically the same circuit board, and this should be pretty easy to mod, if it works at all. I don't know yet. This hasn't been tested at all. I don't even know if it worked before it was in the flooded basement and before it got dirtied up. So yeah, first of all, let's take it apart and clean it thoroughly. Let me take a couple of seconds to thank the sponsor for this video, which is PCBWay, my favorite manufacturer of prototype circuit boards of all kinds. They offer excellent service, super high quality PCBs, and delivery and production is super fast. Check out the link in the video description in case you want your own PCBs manufactured by them. I can highly recommend them. Back to the REU. This plastic case doesn't have any screws, it's just clipped together, and as you can see, this already comes apart on one side here. So I'm just going to use a spudger tool to carefully separate the halves. I think somebody was already in here with a screwdriver. There's some scratches there. I'm just using a plastic spudger tool here to not cause any more damage. So this should now just come apart, I guess. Let's see. And there's a really huge metal can in there. There we go. Oh, okay, and some of the posts that hold this together broke off previously. I don't think I broke them off. Yeah, this is like half coming apart. You can see these posts here that the circuit board and also the top case clips on. So we can probably carefully lever out the circuit board here. Yeah, that should work. Let's see. These, of course, easily break off because the plastic is old and brittle, probably. It's a 1985 made device. So this is the bottom case, and as you can see, there's some remnants of the flooding, some dirt in there. We are going to give this a good scrubbing. This metal can actually is one piece, so it's just folded over the circuit board, so we can fold it open. Oh, that's pretty dirty. As you can see, there's not much on here. There's 8 41256 RAM chips, couple of capacitors for smoothing the supply voltages, mostly, I think. And there's this MOS 8726 controller chip. This is a memory controller chips. So this actually was made in 1987, according to the date code on this chip. It says 27th week 87. At least this chip was made in 87. Yeah, this has a cardboard lining on the back to not short out against the metal case, obviously. Circuit board looks in rather good condition, actually. This is artwork number 312536, and it's a revision 1. You can see by this jumper that says cut for 512K, that's this spot here, I think, that this is the same circuit board for all the memory expansions of the same series, and you can just configure the circuit board by cutting this jumper. This is already configured for 512K, so as you can see, this has been cut from factory, because I guess it's the same configuration for both 256K and 512K. If I'm correct in that, we should just be able to populate these footprints here with RAM chips. It already has the smoothing capacitors. These are like little ceramic capacitors that are smoothing the 5-volt rail that goes to the RAM chips. I think would be the common thing to do. You can see there's 2 rows, and they even populated the row that isn't used that is in place for these RAM chips that aren't populated. So probably they just didn't populate these for half the production for these cards, and for the 512K cards they just populated these, and the other parts were so inexpensive that they just left them in there. There is another spot here that is actually never populated from factory. It was planned to have a ROM on here, and that's what this is for. There's actually some aftermarket ROMs that are in existence that you can put on here and have added functionality and some tools on board, because after all this goes to the cartridge port, so you can of course run software from this as well. And that's what this is for. Funnily enough, this says Commodore 128 RAM expansion on top there. So this was initially planned to be an expansion for the Commodore 128, which I believe the 1750 was marketed as. And this is clearly, it's labeled on the outside to be a device for the Commodore 64, and on the inside, on the circuit board, it's for the Commodore 128. So yeah. Works on both machines, as I said. Yeah, most of the dirt actually came in from the top, it seems, so where these cooling slots are. So this RAM chip area here is a bit dirty, but this area here looks absolutely clean, which is good, because these PLCC sockets where our custom chip sits, these custom chips, by the way, are probably very much unobtainium, except you rip apart another RAM expansion. So it's a good thing that this area wasn't affected by the flood to that extent. I am still going to clean the whole thing, but I don't think I want to pour any water, and I don't want to lift this chip out of its socket, I guess, because you always risk bending the pins. These PLCC sockets are notorious for not making good contact, and they wear out really quickly if you pull and insert chips more than once into them, basically. So I'm probably going to spray some contact cleaner in here after cleaning this with some isopropanol, and then see if we can make this work. At the same time, I want to clean the case in some soapy water, and I'm also going to try to clean this in the sink a bit. So I think what I want to do is to just very carefully wipe this down with some distilled water and then finish off with some alcohol. The water is just to loosen the mud part of it for a bit. And yeah, I don't really think the backside needs a lot of cleaning. It's mainly this area here that needs any cleaning at all. And I'm also going to clean the cartridge edge here, which connects to the card edge connector on the C64 or 128. So I'm just going to use quite a bit of distilled water on it as my first pass. And I'm going to make sure that I don't get any or very minor amounts of it into the PLCC socket here. Yeah, but that already takes away some of the mud there. That's good. Yeah, it's looking quite good already. I'm going to do the main cleaning on the PLCC socket with actual contact cleaner, I guess, and with alcohol, just so we don't get any water in there. And you can see that the water, I don't know if it's visible on camera, but it's a bit brown. I'm going to spray some alcohol on it, which will replace the water basically, and then the alcohol evaporates a lot quicker than the water, obviously. And I'm also going to spray some into the socket there now, because that should be safe and evaporate fully. Just going to let this sit for a while and let the alcohol evaporate. I'll be right back. And while the circuit board dries, I'm just going to put the case parts into some soapy water, which is a mix of dish soap and window cleaner, basically. Just going to let these soak in here and scrub them afterwards. I think it is fully dried now. I left it sitting upright. Going to spray some contact cleaner into the PLCC socket here and on my desk as it happens. And I'm just slightly moving the chip a bit so the contact cleaner can do its job. This should be ready for testing now, and I am going to set up a Commodore 64. I already set up this 1541C that you saw me working on in one of my previous videos. Yeah, I have my Aldi C64 set up here, and I'm just going to insert the REU unit into the cartridge port. This is quite the massive cartridge, and it also protrudes over the side of the C64 quite a bit. But this should now be connected to the Commodore 64, so let's see what happens when I turn this on. As you can see, I'm using my homemade Commodore 64 power supply here, which has a higher output rating than the original Commodore 64 power supply. In fact, these memory expansions came with their own power supplies, so you would replace your original Commodore 64 power supply with another one, which was a very similar one to the Commodore 128 one, except it had the round DIN connector for the Commodore 64 instead of the square DIN connector that the Commodore 128 used. I somewhat hope this works, but let's see. Turning on the Commodore 64. And yeah, we get the exact same picture as without the cartridge, which is actually normal. We can use some extra software to test if this actually works. I have the test demo disc that originally came with this REU, a copy of that, and there's some programs on there that you can use to actually test the memory expansion. So let's see. So if you just load the first program on the disk, you get this 1764 RAM expansion menu where you can select the tools that are on the disk. We're just going to go with the test program, I guess. This test diagnostic program will destroy everything in RAM memory of the Commodore 64 and RAM disk. Do you want to continue? Yes. We don't have anything important stored in there. This test takes about 1 minute and will tell you if your 1764 passes or fails when done. Oh, we actually get some screen flicker. That's not good. Probably our power supply is not quite up to the task. But it passes. That seems to work. It all passes. That's one working REU. Yeah, I have a wonky connection on my cable there. That's nothing to do with the power supply or the REU. I'm sorry about that. My self-made monitor cable is giving up the ghost slowly. So, yeah. Pass RAM expansion. That's good. Yeah, so this passes the test. This was the memory test, of course. Should be able... Oh, if I hit run stop, it just resets. So we can just reload our menu program there. We have a very nice globe demo. That's pretty much what Commodore used to show this off to the customers. I'm going to start that. And it's a graphics demo that loads a lot of single pictures into the actual RAM disk. And then it should display a rotating globe. Load RAM, yes, no, yes, maybe, I don't know. Okay, so now it's loading stuff into RAM. 36 images. This might take a while. But this demo is to show off really quick graphics changes for graphics that don't fit into the internal memory of the Commodore 64. So this is all happening in the REU actually. The images are loading from disk into the REU at this moment, and then we should see the rotating globe demo. Hopefully, if everything works as expected. It takes some time to load these pictures, so you can tell by the loading time how much it was. I mean, it was a hilariously huge memory expansion back in the day. 256K of memory. The Amiga had that at that point in time, the Amiga 1000. There was like a whole different level of machine than the humble C64. 36 of 36. We should see the globe rotating any second now, hopefully. Let's see. There we are. Whoa, and it's fast. Awesome. Okay, that's really impressive. I mean, it's not impressive by today's standards, obviously, but it is quite impressive to see something like this running on a C64. Whew. All the images are stored in the REU at this point, and they're just fetched very quickly into memory. Like these are like 36 separate pictures, as we've seen by the loading. That's impressive. But there's another reason to have the REU these days, I guess, and that's this. There is actually a version of Sonic the Hedgehog for the Commodore 64. And this is actually a newly made fan recreation of the, I think, the Master System port of Sonic. And you actually need a 256 kilobyte REU at least to run this. So let's see if it works. It should technically work with this original REU. And as you can see, we can play Sonic! Or at least we can watch the intro so far. Yeah, that works. This is just Sonic. It's just kind of pretty amazing that they pulled this off on the Commodore 64. Yeah, now we got Super Mario Bros. 1 on the C64 and we got Sonic the Hedgehog on the C64. Just imagine if Sega had released this back in the day. That would have been amazing. And probably nobody would have bought a Master System. So I'm just going to clean the case parts, which have been soaking for quite a while now. Yeah, and there's just a lot of mud on there. It's not even yellowed or anything, it's just dirty. Got myself a toothbrush to get into all the little indentations on there. Yeah, I'm just going to let this dry. And as for this metal shield, I'm going to remove the cardboard from it. Yeah, I think I just want to basically clean this with alcohol and scrub it afterwards. As you can see, there was a bit of rust, but it just wipes away. That's just surface rust stuff. It's nothing much to worry about. And while the case parts dry in the kitchen, I'm just going to put some sockets into these locations. And then we should probably be able to make this into a 512K expansion, which would be the 7050. I think I have some 41256 RAM chips somewhere. First of all, I want to put sockets in because that's always a good idea, just in case you have to replace stuff later. So let's do that. I have to free up all these vias, and then we should just be able to solder in some sockets and have this transformed into 512K expansion. Yeah, these are relatively easy to get out. So this is just going to be a matter of some patience. Yeah, that worked rather well. I don't think I lifted any traces or pads. Unfortunately, I don't have enough 16-pin sockets in stock, so I'm not quite sure what to do about that. Usually I would put sockets in here. I might just, for the sake of keeping this as original as possible, I might just solder the RAM chips directly to the board. Dun dun dun. Major plot twist. As it turns out, I didn't have the suitable DRAMs in my parts bin, so I had to order some, and it's a couple of days later. In the process, I also ordered a couple of suitable sockets to put the DRAM in, because you never know how many of the DRAMs you get. These are like new old stock things I got. You never know how many of those actually work. So yeah, let's try to upgrade this to a 1750 now. So here's the DRAM I got, NEC D41256C-10. The last two digits usually are the access speed, or access time rather. So this is faster than the 15 that is on the REU from the factory. And these sockets to fit these in. These are 16-pin small pitch sockets. Yeah, while I'm at it, I also want to replace these actual electrolytic capacitors. There are 3 of those on here, and this one, at least this one, has some, I don't know if it's leaked or if it's just some crot on there, but that surely, I'm not sure if you can see, but this side clearly has some corrosion going on there. So I think it's a good idea to replace all of these electrolytic capacitors. In any case, they are from 1987, probably, so in my opinion, it's always a good idea to replace these with fresh, good brand ones. So I'm just going to do that, can't hurt. I'm just going to play it safe and replace them. Yeah, and here's the kind of corrosion I was speaking of. That doesn't look great on the ends there. This one as well. And this one. They are all at least corroded from the water damage that this got, so probably a good idea to replace them. So inspected all the solder joints and they look good. Cleaned this up with some alcohol. The last thing I want to do before we put the RAM chips in is to clean this edge connections with a pencil eraser. That's just the type of mild abrasive we need. Yeah, there's quite some stuff coming off there. And yeah, they look shinier than ever, probably. Afterwards, you want to clean the eraser residue, obviously. This is a nice method for cleaning these edge connections. And of course, it's important to clean the other side of the equation too. Like the card edge connector on the computer. Like this, yeah, looks much better than before. That's pretty nice. Shiny, as good as new. Think we can populate the RAM sockets now. I got a new toy, or tool, if you will, for straightening the legs, actually. So this is an IC leg straightener, and it has one side for wider pitch ICs and one side for smaller chips, which we need in this case. Usually I just bend the legs on the side of the table here, but let's try this. Should be able to pre-bend the legs, which if these are new chips, which these are allegedly, new old stock, we should be able to bend the legs at the correct angle by just pushing this together. And then we are probably, looking good, we're probably not going to have much of an issue inserting them. Yeah, that works rather nicely. Ah, sweet, okay. Repeat and fade. You still want to be super careful to not bend the legs, especially with these turn pin sockets. You easily bend a leg without noticing and it doesn't make contact. And of course you want to make sure that these notches here point in the correct orientation. That's this side here. Okay, that's actually a useful tool. I never thought I would need one of these, but I heard some people saying good things, so here we are. And it's actually way easier than to eyeball it. Yeah, and actually Commodore used the same circuit board for all their RAM expansions. So the 1700 uses the same circuit board. The 1700 doesn't have this jumper cut. This jumper just tells the controller chip which sort of RAM, DRAM chips it is supposed to address. So cutting the jumper is fine for both the 256 and the 512K configurations, and for the 1700 you have to leave the jumper as is. I'm going to leave it at this, which should now be a 1750 technically in a 1764 case. I put this in the Commodore 64 and interestingly it now fails the RAM test. Let's try that again. It fails. Yeah, turns out I just had to reseat the card again in the cartridge port. It seems that the expansion without using the case is pretty prone to failure. Actually, this RAM test failed a couple of times before I reseated this, and maybe just my studio lights and things like that interfere with the RAM expansion. I also downloaded another test program that should be usable on all the RAM expansions, no matter what you have. It even has an option for an expanded unit. 17XX MEM tester. I'm also going to link that in the description. Option 2 is for 1750, which this technically is now, or an expanded 1764, which this is in real life. So now it actually tests good. Maybe we just have a contact issue or an interference issue with this. Now it tests okay every time, it seems. Yeah, so I guess this is a working 1750 now. Yep. For some reason, I guess it didn't make good contact, or the PLCC socket didn't grab the chip. I'm going to reseat that again and clean it up and test it again. But in theory, this should now be a working 1750 512K expansion for the Commodore 64 and 128. Yeah, it seems we just have a contact issue with the cartridge port there. I just propped this up a bit to be straight, as if this was in a case, and we get the test passing every time now, so that should be good. I guess that was the problem we had here. So the only thing that I want to do, by the way, this case cleaned up rather nicely. There's still some nicks in there and things like that, but it's an old unit, so you get that. I'm not going to repair that. I am going to try to glue these things back on, though. Should be possible to make this fit nicely again. And we are probably, I don't plan on opening this up again anytime soon. Yeah, okay, this one might just be gone. Yep, that's probably gone. But we can still glue back this one, I guess, so we have a bit of a better grip. So I'm just going to use some of the plastic glue. This is Uhu Plast Special, which is a plastic weld glue. So I'm just going to use some of that on here and hope for the best, I guess. This should give me a weld bond connection here. And usually with these broken off pieces, you can feel where they are supposed to go. I just want to make sure this is straight and let it sit for a while. And as for this cardboard piece, I'm just going to wipe it down with some alcohol. It doesn't look dirty, but there's probably some germs on there as well. And all this does is really insulating the back of the PCB from the case. So I'm not too concerned about the looks of this. This is a bit crumpled because it got wet, obviously. So I'm just wiping it down with some alcohol. Now I'm just going to wait for the glue to set. Okay, I've waited what I suppose is a reasonable amount of time. Let's try and put this back together fully. This should fit in here. This should close up. It's just sheet metal, so it's all a bit bent. I hate these things, but yeah, there we go. Yeah, ideally, this should now fit the plastic case. And even more ideally, should be able to close the case fully again. Our standoff hopefully holds. And it should now hopefully just go on top and clip into this one. It doesn't bend out quite rightly. These protruding bits are connecting to the shielding on the Commodore 64, so it's all one giant shield, RF shield. I think we're done. This metal was never really shiny metal. I think it's just galvanized, judging by the texture that it has. Other than that, this should be all nicely together now. Yep, looking good. So, my favorite part, final test run. Yep, that fits nicely. And as you can see, we are still passing the tests for the expanded unit, which this is now. So we officially made a 1750 and also restored a 1764. So kind of, yeah, 2 in 1. I've managed to load Sonic into the REU successfully, so I suppose it works fully. And yeah, I guess that's it for this video. Hope you enjoyed it. Thank you very much for your support on Patreon and on the YouTube channel memberships page and elsewhere. I also have a Ko-fi now. You can find the link in the video description and also the links to my other ways of supporting me. So yeah, that's it for today. Thanks for watching. I'm Jan Beta. Hopefully see you next time. Bye. That's the demo.